Greetings to you, ladies and gentlemen, and welcome once more to Waffle TV. If this may be your first time, this is a platform where we simplify, we exemplify, and of course, we demystify elementary mathematics for your understanding. Last time, we treated trapezium and we looked at the different aspects of a trapezium. We promised you that this time around, we are going to finish up with quadrilaterals. And of course, we have rhombus and kite. In today's lesson, and by the end of the lesson, we should be able to calculate the area and the perimeter of a rhombus or a kite. Without waste of time, we're going to start with the first aspect, which is the area of a rhombus and kite. You may be asking why it is being joined. We've decided to do it together because the same rule that applies for the area of a rhombus is the same that applies for that of a kite. So we're going to do that together and solve some examples so that you can better understand how to solve rhombus and kite as far as area is concerned. And after the area, we're going to look at the perimeter of these two shapes. One thing to take note of is that we may not be able to finish all the aspects because you need to understand what we call the Pythagorean theorem. After we have done our next lesson, which is triangles, we are going to do the Pythagorean theorem, and by the end of that lesson we will be able to redo kite and rhombus so that we can apply the knowledge to solve other aspects of a kite and a rhombus. Let's move to the examples we have, and before we go to the example, let's understand the rule. To find the area of a kite or a rhombus, the rule states that you take half of d1 and d2. What is D1 and D2? D1 simply means diagonal 1 and D2 is diagonal 2. The example says, what is the area of the shapes shown? Now, on the left hand side, we have a rhombus, and on the right hand side, we have a kite. Let's start with the rhombus. A rhombus is simply a square, and the diagonals meet at right angle. So, one line that moves vertically from one vertex to the other is called diagonal 1, and that which moves across, we'll call it diagonal 2. So we'll apply that in this rule to find the area of this rhombus. Area is equal to half d1 d2. Let's substitute. Area will be equal to 1/2 d1. We can take d1 to be 12 centimeters and d2 9 centimeters, so that half of 12 will be 6 times 9, and 6 times 9 is going to give us 50 centimeters square. So this is the simple way that we can apply the different figures in the rule to solve for the area of a rhombus. Let's move on now to kite. How to solve kite? It is the same because the rule remains the same. Area will be equal to 1/2 d1 d2. We're going to take the longer line to be diagonal 1 and the shorter one to be diagonal 2. Area will be equal to 1/2 d1, as we've said, is 12 centimeters, and d2 is 6 centimeters. Half of 12 is 6, and if you multiply that by this 6, you're going to have 36 centimeters square. So basically, if you apply the rule in the various shapes, it's just to identify the diagonals. And one thing you should take note of is that sometimes they give you just one side of one of the diagonals. For instance, in this 6, they may decide to give from the right angle from the midpoint up as 3. So if from midpoint up here is 3, then the other side should be 3, and that together will make 6. So it's just to apply simple common sense if one side is given to calculate the other. Now let's move on to the perimeter of a rhombus or a kite. Perimeter of a kite. The rule states that the perimeter is equal to 2 into a plus b. And what is a plus b? A and b are simply the lengths of the pairs of the sides. We should take note that in a kite, this line and this line are the same length, while this line and this line, this other pair, is the same length. we simply add the two and multiply by 2. If we know this side as 17, then this other side should be 17 decimeters. And if this side is 10, then this side automatically should be 10 decimeters. And perimeter, as we know, is the distance around this shape. That is the length of all the sides of a kite. If we want to apply the rule here, P will be equal to 2 into A plus B. And we know 2 will stand. A will be 17 plus 17, which is going to give us 34, plus B, which is 10 plus 10, 20. P will be equal to 2 into 34 plus 20, 54. And 54 times 2 will give us a total of 108 decimeters. That is our perimeter. Having understood this, we are going to move to the last aspect, which is the perimeter of a rhombus. As I promised you in the beginning of the lesson, we will better understand how to find this when we must have done the lesson after next, which will be the Pythagorean theorem. So don't miss this because it will facilitate your understanding of what we are going to do now. But pay attention because it may be a little bit tricky. The rule here states that perimeter is equal to side times 4, which of course reminds us of the perimeter of a square. And we said a rhombus is also a square because all the sides are the same. So the rule is side times 4. Therefore, our concern here is to find the side. Let's name this side X, because if we find one side, we multiply it by 4 to find the perimeter. To better find it, we can do it this way. This is A, B, C, and D. Let's call this also E. To find this side, we have to extract this triangle because the diagonals cuts the rhombus into 4 equal triangles. So we are going to remove one triangle, that is triangle ABE. And triangle ABE looks like this, with this side 15 and this side 8. This is the opposite side, this is the adjacent side, and this is the hypotenuse. And to find the hypotenuse, the rule is A square plus B square equal to C square. So we'll use the figures that are given to us to substitute. Let's name this side A, this side B, and this side C. So our A will be 8 square plus 15 square equal to C square. Or let's call it X square. What is 8 square is 64 plus 15 square is 225 equal to X square. 64 plus 225 will give us 289 equal to X square. To do away with the square or to find X, we simply find the square root of both sides, so that the square root of 289 will be equal to 17. This side, or our hypotenuse here, will be 17 centimeters. This is just the side, but we have been asked to calculate the perimeter. So therefore, perimeter P will be equal to side times 4. And we know our side now as 17 times 4, which is equal to 68 centimeters. This is what we had for you today, and we believe you've learned something. We look forward to meeting you in our next lesson, which will be triangles. Don't miss this lesson. Also, don't forget to subscribe to our channel. Click the notification bell so that each time we share a video, you'll be notified. Until then,